When Cursor launched Origin in August 2026, tech media immediately framed the release as an aggressive threat to Microsoft's $2 billion GitHub monopoly. But if we look past the headlines and read Cursor's own release notes, we find a different architectural reality. The documentation states clearly, pushes keep going to GitHub, which stays the source of truth. This is a strict canonical source constraint. Origin is not built to replace existing code storage repositories. It operates as an optional, two-way sync computation layer designed to avoid the risks of a storage migration. This presents an architectural paradox. If GitHub remains the ultimate storage locker for enterprise code, why did Cursor invest heavy engineering cycles to build a proprietary hosting and review interface on top of it? The answer lies in the limitations of legacy Git forges. Platforms built in 2008 are built around human review rhythms. Fleets of autonomous coding agents operate at extreme commit velocities, requiring infrastructure that can manage high-speed scale without bottlenecks. Origin functions as a high-throughput compute engine for agents, regardless of where the underlying code is stored. The shipped scope of the Origin early beta is highly specific. It includes repos, pull requests, code browsing, and a dedicated CLI. This diagram shows the bidirectional data architecture syncing the two platforms. GitHub acts as canonical storage, while Cursor Origin functions as the compute interface. Specific elements of the software development lifecycle, like pull request comments, commits, and file diffs, flow between the two nodes in real time. This creates a bifurcated workflow. Human reviewers remain in the GitHub environment they already know, while automated agents and developers operate inside Cursor. Because of this sync, Origin hooks directly into existing third-party CI/CD pipelines, like Vercel and Depot. Existing GitHub actions continue to run without requiring reconfiguration. Traditional repository migrations demand severe operational downtime. A mirrored integration sidesteps that entirely. The immediate tactical benefit for enterprise teams is the zero-friction testing of new AI workflows. Rollback is instantaneous. If a test fails, you simply disconnect. The underlying GitHub repository state was never altered. This bidirectional mirroring eliminates enterprise switch tests, allowing organizations to securely test agentic development without disrupting core CI/CD pipelines. Widespread AI adoption usually begins as a shadow IT vulnerability, with individual developers using isolated tools outside of corporate compliance protocols. The Cursor Organizations release provides the mechanism to elevate these tools into governed infrastructure. Consider an enterprise engineering department divided into 3 isolated silos: payments, platform R&D, and offshore contractors. For the highly regulated payments silo, administrators apply a strict role-based access control policy, enforcing a locked on-premise model configuration. The platform R&D silo requires experimental velocity. They receive an expansive access policy, utilizing GPT-4o with broad codebase access. For offshore contractors, the system enforces strict cost and access parameters. These granular, per-team policies roll up into a single centralized audit log and a unified billing invoice for the CTO. IT governance now functions as a laboratory for organizational A/B testing, moving beyond the traditional role of gatekeeping. Leadership can directly measure the defect-to-throughput ratio of different AI models across different workloads and teams. Segmented governance and model constraints provide the security required to deploy these AI tools as standard enterprise platforms. We have to look at the flaw built into Git platforms designed in 2008. The core friction is a mismatch of speed, human cognitive rhythms colliding with the exponential commit velocity of AI agents. A parallel, agent-driven workflow, which is constantly testing multiple code variations simultaneously across the codebase, demands massive raw throughput. Serial, text-heavy pull request queues create mathematical bottlenecks that choke this level of throughput. To solve agent setup latency, Cursor engineered a compute layer called Cursor Builds. Before an agent is ever requested, the system clones repositories and installs dependencies in the background, preparing the environment ahead of time. The performance yield is immediate. Agents boot instantly into a prepared environment with a 3x faster time to first token. But these shipped features only support the UI. The logic for true agent autonomy is explicitly deferred to future updates. This roadmap requires provenance, the ability to inject metadata tracking exactly which model authored a commit. It requires automated conflict resolution, where sub-agents repair broken pipelines without pinging humans. It requires stacked PRs, allowing agents to bypass serial queues by securely chaining dependent branches. Non-human actors require first-class permissioning, rather than operating on borrowed human access tokens. Traditional text-based diffs must be replaced by machine-parsable diff formats for agent-to-agent reviews. Until this deferred scope ships, Origin remains a human-shaped host, equipped with a chat assist layer. True agent-native infrastructure is defined by the autonomous CI/CD loops and provenance tracking built on top of the code, not by where the code lives. As agent velocity increases, the software development lifecycle requires an interface optimized for machine throughput as well as human readability. For engineering leaders, the immediate directive is strict: do not attempt to migrate storage off GitHub today. The recommended deployment strategy is to utilize cursor organizations to run controlled, segmented workflow pilots. Decouple your storage strategy from your compute strategy. This chart maps the shifting value proposition within the developer stack. Value is moving away from static code hosting. Code hosting is becoming a commoditizing utility, similar to basic cloud storage. The enterprise moat of the next decade is not the repository that holds the code. It is the high-throughput compute and review environment wrapped around it.